everybody, welcome back to Ed's Metalworks. We got a continuing job here. If you watched my last video, we're repairing some sprockets for a lawn aerating machine of some kind. But we got one made, or one repaired. He had purchased a new one, but he needs two more. And I think I stated in the last video that they were about $100 a piece, which I've established I can't make them for $100 a piece. I'm a very slow machinist and can't charge him by the hour on them jobs. So anyway, I decided that there's enough machine work in them that I don't do very often, that I figured I would go ahead and tackle a couple of them. He'll give me a few bucks for them, I'm sure. But we'll get him fixed up. Probably less than $100 for sure for each one. But I'll show you what we got going here and how I proceed. These are the sprockets you probably saw in the last video. This one's welded up pretty good. I haven't taken it apart yet. I did take this one apart, cut the weld off of it. And I think I stated in my last video I thought that was a shouldered shaft where the sprocket went onto, where the sprocket pressed onto there. But lo and behold, it's a taper. And that's the one thing I surely didn't plan on was having a taper on there. But anyway, we're going to cut this taper. I'll show you. I already made one for practice, basically. It does match this shaft here. And I may cut the taper cut on another one. But anyway, I got my drawing here telling me my dimensions, but you can see this taper bottoms out at about an inch from the end of the shaft. So that's what we're going to do here. So we'll go over to the old Powercraft lathe here where I'm cutting the tapers. Of course, I got another shaft ready to go in here, but you can see I have my distance marked on here. 1.04 is what it is with the caliper. But anyway, when I originally set this taper up, I set the original part in here, and I just held my ruler on here. I had a blank tool post on here. I've since moved this, which once you set your compound, I don't think it makes any difference where you have your tool post, because it's going to run on the same line as the compound there. So anyway, I set it up originally with just a flat ruler on the original taper, and then I moved the compound until I matched up with that ruler. Kind of a caveman way to do it. I did put a test indicator on there, and lo and behold, I was dead nuts on that deal. So, but anyway, I just slowly cut this taper back until it ends at that 1 inch mark there. We'll go ahead and do that and show you how that gets done here. Alrighty, here we go. And then cut this taper. I got the cross slide or the lock down so it don't move from this point. So I feed in and feed this way with the compound there. All right, here we go. All right, I use a steady rest here because I got so much stick out. My bore is only 3/4 inch and these shafts are 1 inch, so I can't run it up next to the chuck. So we're just stabilizing a little bit with that steady rest. So all right, we'll run in here for a touch. Still get a little bit of chatter on it. Just take small 10,000ths cuts basically. I don't want to go too fast because number one, the chatter. Number two, you sneak up on that. Maximum length of the taper line pretty quick, really. These go inside that sprocket and then get welded on. Why they use a taper, I don't know. I suppose that's a pretty strong. These are drives for the power drive on the aerator. The other end of this shaft gets turned down for the threading, and the keyway, that's where the hub goes that the tire bolts on. So tire and wheel assembly bolts on there. So see, we're sneaking up on that 1-inch line there. Now don't, all you real machinists out there, there's probably a better way to do this. More correct machinist type way, but I'm kind of just a hack on these lathes and stuff, so but we get it done. Now we're not going to take as big a cut now, being we're getting close to this line here. Just a couple thousand. Oh boy. Let's take just a pass without moving. See where we end up here. Maybe another couple. Couple. This should probably get us there, hopefully. Boy, that's about it. Let's take a pass without moving and see where we end up here. No, just barely. 1,000. Alright, we're at the line. We're close enough. Another pass without moving the dial. We're there. Alrighty, we got our taper cut. We'll move this back out of the way and get that sprocket and see what it feels like on there. There we go. What I will do is I'm going to press these on a little bit before I weld them. Press them on that shaft before I weld them, but that's how I cut that taper. We'll move on to the rest of the machine work on it. Alrighty guys, well, we established our from the end of the taper to here distance, and that's what I got marked here. This is going to be a little long, but I planned it that way anyway. So, but anyway, that's what we're going to cut now. Cut this down for the 5/8 18 threads. So go down to 620, I think is what I went to. Small machines, I don't take big hog cuts, so I'll just do a few cuts and bring you back at the end. No sense me, you watching me take little cuts off of here. But just to establish this length here. Meat on there in case I got to adjust that length at this shoulder point. Get the idea of this. We'll be back in a bit. Alrighty guys, we got both our shafts turned down to the 5/8 18 thread size. Now, I'm no good at threading on a lathe, so I'm going to be safe, being I got a little work in these shafts. I just use my good old little giant die set. So we'll get that started here. I turned the cutters around so that we can get down to the base of this. I just run my chuck up there to get everything squared up. I only do this to get it started. I'll finish the rest of it in the vise. But this is just to get me started here. Get good 6 or 8 threads on there, and we'll take it out and go in the vise with it. For one thing, I don't have a tool that'll thread up against the shoulder like that. I'll have to grind me one someday. My pre-ground one won't fit up against the shoulder. These I can get pretty much down the shoulder by flipping the cutters around too. All right, got a pretty good start on that. Back this out of the way. This out of the way. And we'll take this out and put it in the vise. guys. Come on along. See if I can get you set up here somewhere where the swing of my die won't interfere with anything. Sun is shining bright today. Coming through the shop. All right. Got some copper jaws in here to protect the shaft. And crank down on there pretty good. Sorry for that glare back there because of the sun coming through. I had a shade on my window, but it has long left me. Okay. Now we'll just run this down here by hand. Tap the juice. I'll just take a turn and back up and break the chips off. That's how I get my workout for the day. Goes down there without much pressure, but still it's a little bit of force. More juice here. Not a quarter inch to go yet. I don't know where I got this, but this fluid, it's a kind of a vintage can. I might have to put that on the shelf if I ever empty it out. Like I said, I have no idea where it came from, but Mr. Happy Tappy here. I always pick up stuff at estate sales and junk like that when I get a chance, but sure haven't been to any lately. They've been worth a dang. I like vintage little drop oilers, little cans, like your 3-in-1 oil and stuff like that. Kind of find them now and then. All right, we hit the bottom. Back this off here. Give it a little juice. Alrighty. Phew. Like I said, that's my workout there. We got a good fit on that. Like I said, let me blow that off a little bit. That down on here. They don't, with that die set up the way it is right now, it don't go all the way down to the shoulder. So like I think I mentioned, I gotta flip the cutters around in that die head to cut that, because I'm running the taper, the starting tape side of them dies. So we'll go ahead and change them out real quick like, and run that back down on there. Okay. These are set mostly, so no matter which way I run them, they seem to give me the same cut. They're set up against the line here for the 5/8 holder, so let me blow that out. Okay, now what we have is the finishing side of the dies toward the face, which is the way they should be ran anyway, but when you're going up against the shoulder, you got to make do. So we'll get this started on there and run it all the way down to that shoulder. Sorry for that glare back there again. Geez, it's worse than I thought, but I enjoy the sunshine at this moment. I'll get that started on here. Give it a little juice. Our handles on here. There we go. Need to find detent in that die welder. I don't know what kind of nuts they spin on these, but must be some kind of one-time use deal, because, or else I don't know how he takes them off, but a lot of them come in with threads all stripped out on them. Okay, there we go, run down against that shoulder. Now the nut should run down there all the way and shoulder out. There we go. Alrighty, there's our threads. Come on, good. Might bevel this starting point a little bit, but all we got left to do now to these is cut the keyway in here. 1/4 inch keyway, 1.5 inches long. We'll get started on that. Okay, we got a shaft set up in our mill here. We got a stop set for our 1.5 inch length, and we already centered it, half the shaft and half the cutter. Now we'll find our depth, and we'll go ahead and get this keyway cut. I don't use this mill too often, so we do have a dial indicator for the depth up and down, so that helps matters. Alrighty. This down until we get a full width cut here. I'll call that our 0. Back off a bit here. Let's go down 50. I do have power feet on this, but I don't trust it. I'm not, like I said, I don't use this very often, so I'm just feeder by hand to be safe. Nice and easy. to final depth. It's 1/4 inch keyway, so we're going to go a little bit over 1/8 of an inch. We'll go 1, 2, 5, 6, 7, 1, 2, 7. A little bit of wiggle room. Alrighty, let me clean it off a little bit. Whoop, sorry about that. Go ahead and get that out of there. Alright, we got us a keyway, a little file work. And that one will be ready to weld on the sprocket. Well, we're coming into this shaft and sprocket project. We went and pressed our new shafts into these sprockets. Luckily, I was able to cut the welds off of both these sprockets so we can reuse them. We pressed them in there. As much as my 12-ton press would make it go to make sure that taper in this sprocket was good. Our measure from the sprocket to the shoulder is right on the money now. So anyway, I'm using my jig that I used in the previous video when I welded one of these, but you can see I'm supporting the, I don't know if you can see, but I was supporting the shaft with a set collar and then holding down on the sprocket with these two clamps. So I got it sprayed down with some anti-splatter and we're gonna let her rip. I'm not gonna rotate it like I did in the last video. I'm just gonna make a half pass and half pass on it. we'll weld up that other one, but you guys don't have to watch that. Same process over it again. But anyway, thanks for coming along with me. This is a good little project for me to remember how to do a few of these skills in the machine and on the lathe, but don't get to do a lot of that, or don't have called to do a lot of it. But it's always good to keep your skills sharp, do these projects. Like I said, one of these shafts, new from the manufacturer, is about $100 bucks. Now, I can't make these for $100, at least I don't want to. But I did tell my friend with these go-to that if he gives me a little something, I'm gonna make a couple just for the practice. Anyway, thanks for watching Ed's Metalworks. Like and subscribe and comment if you will, and we'll see you on the next one. This is Ed Metalworks signing out.